Welcome back. In the following topic discussion, we are going to look at database systems and how these can be applied as applications in organizations or perhaps our daily lives. Now we're going to look at the following aspects. We're going to define the general data management concepts and terms. We're going to look at various examples. We're going to consider some of the advantages that companies could experience when they apply database approaches. We're going to talk also about logical and physical database design considerations. How do we go and create a new database? How do we interpret data? We're going to look at the common functions that should be present in all database management systems, identify some of the more popular database management systems, and then we're going to discuss some other data related issues such as business intelligence, data mining, as well as other concepts. Now let's start to look at data and how data can be placed within a database system. Now if you recall, in chapter 1 we talked about data and information. So we said data was actually raw, unprocessed information. So it's information that we have, but we can't really detect the meaning of it. It comes in various forms, such as text, numbers, images, audio and video. And then once we give meaning to the data, it actually becomes information. And those we typically find in the form of documents, of audio recordings, of photographs, and then video recordings, animations, etc. Now, where does a database fit into all of this? A database allows us to go and organize and manage all of our data and all of our information that we've gathered, either for personal use or for the organization. So if you think about your cell phone and you think about your contact list, the data contained inside your contact list, if it pertains to one person, a friend, it becomes information. If you have a list with a lot of friends and you want to keep a record of all of the information, that is saved in a contact list and that becomes a small database. So a database is a well-designed, organized and carefully managed connection of all your data resources. Now let's go and look also at the term database management systems. A database management system extends the purpose of a database. So this is usually where we've got a set of programs, and these programs allow us to manipulate the database, and they also provide an interface with your users. So if you think about it, in this particular topic we're going to look at databases in more detail and how to develop them, but your general user wouldn't be concerned with this, and they would typically just want to go put in information, retrieve information and search for information. So that all of those functions would be contained within a database management system. It's important to realize that in today's lives, we wouldn't be able to complete a lot of business activities and perhaps personal activities if we didn't have our data organized in a particular manner. Think about your cell phone, working with your contact list, your WhatsApp messages, your SMSs, those are technically also saved in a database. Facebook is a huge database, and the list goes on. Now let's go and talk about data management. As soon as we start to talk about databases and the content that we're going to have, it's important that we look at the hierarchy of data. Now the hierarchy of data starts with the smallest level of our information, and then it goes up to the level of your physical database. So what do we start off? We actually start off with our bits. Now if you think back to chapter 2, we learned that bits are represented with ones and zeros. So there's either a circuit or there's no circuit. That allows us to complete processing on our computer through the CPU. It sends information to memory as well as to secondary storage. So the smallest unit that we have is actually a bit. Then from a bit it goes into a byte. When we have 8 bits, that series of 8 bits, ones and zeros, becomes a byte, and a byte represents a character, a symbol, or something that we want to give meaning to. For example, if we look at in terms of computing concepts, for each one of the alphabetical characters on your keyboard, uppercase, lowercase, there is a specific byte representation in order to get that character. Now, once we've got a collection of bytes, we're going to create a field, and we're going to talk about this in more detail a little later on. Now, a field can typically be a name, a number, or a combination of characters, and these usually describe any object or activity that we want to record information on. So coming back to our cell phone example, our contact list, if I say that we want to set up a contact list, some of the fields that we would find inside would be the telephone number, the actual contact number, there might be one or more, a surname, initials, a name, then we might have a photograph, we might have date of birth, as well as more information. So all of those are actually fields. From the field level, it actually goes on and it becomes a record. So if we got a combination of fields, name, surname, contact telephone number, date of birth, that represents one record because it's one entity information that we actually want to record. So that's your friend's information that we want to record. So it can also be defined as a collection of related data fields. A set of records is known as a file. So if you think in terms of your cell phone, your contact list would be seen in the data management concepts as a file, a collection of related records. If you have multiple files, that becomes a database. Now, the best way to explain this perhaps is to use something like student information. We might have files where we've got registered students. So when students come to study, they register. So that's your one file. We might have another file where we record all the marks and the modules or subjects. And we might have another file where we record, for argument's sake, let's say, hobbies and likes and dislikes. So these three files could be taken and together they would be seen as a small database. So all of these are known as the hierarchy of data. Now let's look at it in another context. Again, we're going to start off with the smallest one, working our way up towards the highest level. So on the smallest level, we see we've got a combination of bits, which is also known as bytes. There's 8 bits. These 8 bits represent the character F. When we start adding a bunch of characters, in this case Fisker, it indicates a field, in this case last name. If we have various fields, so let's say for argument's sake we've got a social security number, last name, first name, and the date on which this particular person was hired. So we've got 4 fields. These are now representing one individual, so now it's known as a record. A set of records are known as a file, in this case a personnel file. And then if we've got multiple files, now it's known as a database. So we might have a personnel file, a department file, as well as a payroll file. So these are the basic blocks, building blocks that we need to know of. Now let's go and take it to the next level. There are some additional terminology that we need to look at when we talk about databases. The first thing is people typically talk about a table. Now a table in most cases represent a file. So you've got a bunch of records, and those records are typically in database terms placed within a table. You will find that there's an indication of records, so each row represents a record. When we have many of these, it's referred to as many records. When we're talking about fields, these are also known as attributes in terms of database concepts. So if we just talk about everybody's first name, that would be attribute, surname would be attribute, address one would be attribute. If we look at the next set of terms that we need to look at, as I've indicated, the attribute typically is a characteristic of an entity, for example, employee number, last name, first name, etc. Then they start to talk about a data item. Now, a data item is a specific value of an attribute. So, for example, if we look at this list here, a data item would be only that value. So, under the first name attribute, a data value for the first record for first name is actually Francine. So, each of these blocks represents a data item. Now, in terms of databases, we also need to talk about a primary key. Now, a primary key is one or more fields that allows us to uniquely identify a record. So, for example, if we talk about people, how can we identify a person uniquely? The answer would typically be either by its identity number or student number, personnel number. So there's something unique to you as an individual that allows us to get only your details. So again, primary key, if we look at this information here, what makes all of these attributes unique? And in this case, it's the first one, employee number. We're going to presume that everybody will have a unique employee number. Reason for it being unique, if there's duplicate numbers, we're going to get incorrect data, as well as we're not going to identify the person that we intend to identify. So it should always be a unique number. In certain cases, you might also find that there's a foreign key present. Now, a foreign key is typically where you've got a primary key that is used in another table. Now, as we go on, you will gain a better understanding of how we use foreign keys and under which circumstances. But for example, returning to our data here, department number would be a foreign key for each and every employee. So let's say we've got the IT department, which for argument's sake might be 257. There might be multiple people working in that particular department. The same thing for the next one. Let's say this one's the accounting department, and again there would be certain people associated with that particular department. Now, the next definition that we need to understand is actually called an entity. Now, entity, we've started to mention that in one of the previous slides. An entity can be defined as a person, a place, or a thing, or even an activity or task that we want to record information for. So we're going to take data and we're going to gather it, store it, and maintain that data for that particular aspect. So if we talk about, let's say, you want to record your personal information, you go to the bank, then one of the entities that they need to have in the database would be customer details. Another entity might be, let's say for argument's sake, your next of kin, or it might be your packages that you have with them. So it should be something that we want to record information on. So if we look at the two data sets on screen, we've got two entities. We've got a customer entity or customer table, meaning that it's going to contain a lot of customer records. We're going to have an order table which will contain various orders. Now, just to recap on some of the previous definitions, in order to identify our customers uniquely in the customer table, we need to have a primary key. The primary key in this case, which makes it unique, is customer number. If we look at the order table, again, in order to identify them as unique values, we need to have a unique attribute, and in this case, it's order number. Now, just for interest's sake, if you peek to the right here, what do we start to see? And this is where the foreign keys come into play. For this first order, we find that customer number 10, which is Jane Wilson, has ordered a swivel chair. For the next order, John Smith ordered a coat rack. For order 102, Jane Wilson ordered a whiteboard, and then for order 3, Desmond Patton ordered a computer desk. So this now links the orders to the actual customer information. Now, just for interest's sake, we're jumping the gun a bit. There's a problem with the first set of records. What do we see that might be a little suspicious? If we look at records number 10 and 12, what do we find? We do find unique customer numbers, but we actually find a duplication of information. So that might present us with another issue. But that's a matter that we will discuss in a short while. Okay, so typically such duplicate records we would remove, and we would have one customer number, and that customer number 10 would be associated with order 100 as well as customer number 10 with order 102. So as I've indicated, the customer number is a foreign key within the order table. So customer places orders. So in this case, we've got a customer entity and we've got an order entity. Again, I'm going to perhaps preempt what we're going to talk about in the next few slides. A customer might place many orders. For example, if we look at this situation, customer number 14, Susan Haynes, hasn't placed any order. The same with customer number 13. So a customer might, that circle indicates that it's optional, it's not required that everybody should place an order. So a customer might place multiple orders. If we look here, we see that Jane Wilson actually placed 2 orders. An order should be placed, it's required, be placed by one customer. So you can't have customers sharing orders. So that's typically the terminology that you guys are going to see that we're going to carry through, right through this topic discussion. Now let's continue with a little more terminology. The next few things that we need to talk about is the traditional approach to data management. Now, typically, what we found in the past was that companies would have specific operating systems and operational systems, and then each of these operational systems would have specific data files dedicated to those systems. So all your information would have been saved in text files, and then you would have retrieved your information from there through programs, as well as possibly update information into those files. A newer approach that we find is the database approach to data management. Now with the database approaches, because companies are growing and we have globalization on all those aspects, they realized that they needed to share information, and that they needed to share information perhaps between databases or between tables, records. So you might have something like a student registration record or table, as well as the marks table, and then those should be interlinked to each other. So the main idea is sharing a pool of related data. Now let's just talk about this particular image, and this represents what we've seen with the new approach, the database approach to data management. Typically we would find a database with various, in this case, files or tables. So we would find payroll, inventory, invoicing, and various other tables. These would be managed through a database management system, which we're going to talk about a little later on as well. Now the DBMS represents you with the interface. So it's the interface between the database and your various applications that you use in a company. Those applications will be accessed by your users. So users will typically add information through the application, through the database management system, into each one of these tables, or they would request reports through the applications yet again. So we've got the database interacts through the DBMS with the interface. We've got our applications, and then users typically interact with our applications. Now, the last set of concepts that we need to talk about for this section is what are some of the considerations that we need to take into account when we create a database. So first thing is, we need to look at 4 things. You need to look at your content, the access to that content, logical structure, and the physical organization. So if we talk about content, what content should be collected and what is it going to cost us? So how expensive will that be? If you think back to chapter 1, characteristics of valuable information, we talked about how costly is our information. So is it really worthwhile to go and gather and collect that? We also need to talk about access. Who should be provided access to that information and when can they have access to it? Because as soon as you make access open to everybody, you would typically find that people go and they make mistakes with the data, they use data for the wrong purposes, and if we think about more secure data that we require nowadays, people might start to misuse your information, steal your information. So who has the rights to view that? The third thing we need to talk about is logical structure. How should the information be structured or arranged in order for it to make sense? And that's what the next section would be about. So we're going to take our database, we're going to create the tables, the relationships between tables, and we're going to show how information flows from one table to another table. The last aspect that's important, physical organization. Where should that information be physically placed? On our company computers, on our personal computers. So content, what is it that we want? How much is it going to cost? Who should have access? How should it be arranged? And lastly, where are we going to save that? So in the next section, we're going to talk about data modeling and data characteristics. And we're going to look at that in more detail.